So, good morning, students. In today's video, we are going to cover this topic, Earth's interior. Okay, so based on seismology, Earth's interior can be divided into three main layers. So, previously, we have covered this topic, seismology. Okay, and like seismology, in that we have seen that how the earth scientist discovered these layers and study the earth's internal structure with the help of seismic waves that are caused by earthquake, nuclear outbursts, etc. So based on that, we earth scientists have I'm sorry so based on that, earth scientists divided the in Earth's interior into three main layers: crust, mantle, core. I'm sure you have heard these terms before. Let's go a little bit deeper into these. So, the crust is the outermost layer. It is also known as lithosphere, mostly made up of basalt rocks. So, firstly, let me give you a rough structure. See, we have this is not the exact structure. Okay, I just want you to imagine it. The first is the lithosphere inside the earth's, just like we have like hydrosphere, atmosphere outside the earth's internal structure. In earth's internal structure also we have these different spheres. So first one is lithosphere, second is asthenosphere. I'm sure you have heard about these, till 48 kilometers, something like that. Then we have mesosphere, and then we have barysphere. Okay, so these are the four layers, and the crust. It is also known as lithosphere and is made up of basalt rocks. So the basalt rocks is basically blackish in color, and it is made up of like igneous rocks. That is, igneous rocks like are made from the cooling down of magma and lava, and magma and lava basically come out from the volcanic eruption. So basalt rocks are basically magma and cooling down of magma and lava. Okay, it has two parts, namely upper and lower crust, and the thickness is 20 kilometer on the average density. And then we have like the asthenosphere till 48 kilometer. Average density of upper crust is 2.8 and the lower crust is 3. So this variation in density, why it occurs? Because of the increase in the pressure. As pressure increases from the upper layers, as the pressure increases from the upper layers, the particles come closer. Seismic waves lose their speed gradually both in upper and lower parts of the crust. So the seismic waves slow down and loses their speed in the crust, just because the crust is not much denser. So what happens when the layer is denser? That means the particles in the waves, they push each other much faster, and because of that the waves travel faster. But if the medium is not much denser, so these particles don't push each other that much faster, and this leads to the slowdown of traveling of waves. So yes, the crust is not much denser than the upcoming layers that we are going to study. Mantle. So second layer, It is characterized by the abrupt rise in the intensity of the earthquake waves. So these seismic waves basically caused by the earthquake, so that's why they are also called as earthquake waves. So the mantle, it is characterized by the abrupt rise in the intensity of earthquake waves. So this uh, what happens is these earthquake waves, okay, they their speed increases when they are coming into the mantle, because mantle is much more denser than the crust. It is known as mesosphere, located at the boundary between lower crust and the upper parts of the mantle. So then we have the mesosphere, um, and speed is 6.9 kilometer per second at the base of the lower crust, and it rises due to discontinuity. So the speed increases. Why increases? I'm just repeating this line again and again. As the medium became, or the layer became denser, the speed increases of these waves. Okay, as simple as that. Now we have the discontinuity. So we have talk about discontinuities before. Basically they present between these layers, and because of them we are able to know that the new layer is coming our way. It lies between the separation zone of the lower crust and the upper mantle. So who lies this discontinuity? The mean density of this layer is 4.6 gram per centimeter cube, and it's spread out till 2900 kilometer. Presently, the mantle has been divided into three zones by IUGG, that is International Union of Geodesy and Geophysics. And they divided the mantle into three main layers, that is Moho discontinuity, and then this 200 to 700 kilometer, and then this 700 to 2900 kilometers. So these are three divisions that are created by this organization IUGG. It is rich in silicate minerals like iron and magnesium. So basically this line is not totally correct. What it want to tell us is that this layer contains silicate minerals. So silicate minerals, like if you add the silicon and oxygen with any metal, it will consider the silicate mineral. So you can say that the iron and magnesium are mixed with the silicate minerals and they make the silicate minerals. So this is a rough diagram. Okay, as you can see we have the crust, and the crust is divided into two parts, oceanic and continental crust, and it is included in the lithosphere. Then going deeper we have this Moho discontinuity, and its full name is Mohorovicic discontinuity. Then it tells us that the new layer is coming, and that new layer is mantle. Okay, so till now everything is clear. Now lastly we have this core. At the very middle of Earth's internal structure we have this core, and it is very hot. It is known as the barysphere. So now we have the barysphere. Extent of core is 2900 kilometer to 6371 kilometer. So it's spread out from 2900 kilometer to 6371 kilometer. So basically if you ask me that which layer is constitute like covers the most part in the Earth's internal structure, I would clearly tell you that it's mantle. Okay, it covers almost like 80% of the Earth's internal structure. Then we have the core. So it is marked by a boundary known as Richard Gutenberg discontinuity. So this when this discontinuity comes, we like we came to know that new layer is coming, that is core, and the density changes from 5.5 to 10. So the density increases as we go deeper, we know that, and the speed also increases of these waves. So these waves definitely travel faster in the denser mediums, and at the 5500 kilometer distance, the core is divided into two parts, outer and inner. So outer and inner, outer core denotes the loss of secondary seismic waves, thus it tells its molten state. So this outer layer is in molten state. Okay, and then we have the inner layer, and the core is basically made up of these metallic materials, iron and nickel. So as you can see that these seismic waves, like here you can see that the loss of loss of speed of secondary seismic waves tells us that it is in molten state. So that's how the earth scientists came to know that which layer is coming, and it's things like that, because of like slowing down of these seismic waves or speeding up of these seismic waves. So I hope you are able to understand seismology much more better. Now today's homework is to make an image in your mind explaining this concept. So I want to improve your imagination, because at Albert Einstein says that imagination is much more important than knowledge. So with this, that's it for this video. Thanks for watching.